GTA Math. What's up? Today we're gonna do a complex fraction. Just to give you a heads up, this one is gonna be a little tricky. There's a lot of steps to it. And just to simplify things, I want to go over a quick rule. So whenever we have negative exponent, negative exponents, like x to the negative 2, this is really the same thing as 1 over x squared, right? If we have something like 5x to the negative 2, hint, hint, this is really 5 times, I'm going to just do a parentheses, 1 over x squared, which really just becomes 5 over x squared. Just giving you a forewarning so you're not surprised at what you may see later in this video. Oops. Crazy. Come on, Microsoft, work with me. But let's get to this problem, actually. That's what's really important. So we have a complex fraction as stated. The first thing we're going to do is rewrite the problem. So step 1 is going to be rewriting. So 5x to the negative second power is going to be 5 over x squared minus 3y to the negative first power, which is going to be 3 over y. And then we're going to do the same thing to the bottom. We're going to rewrite it. So this is going to be 1 over x plus 1 over y. So I'm going to call this next step LCD. And this is just getting the least common denominator for the complex fraction, which is very important. So we know in this problem, we're missing an x squared here, we're missing a y here. So we're going to multiply the top and bottom by x squared, because that's what we do with fractions, right? Whenever we're making least common denominators, we multiply what the other thing is missing. And we do that to the top and bottom. And right here, we're going to multiply this by y over y. And then here, we're going to do the same thing. This is missing a y. So it's going to be y over y. This is missing an x. So we're going to multiply horizontally. So 5 times y is going to be 5y minus, and then this is going to be 3x squared, because 3 times x squared is 3x squared. And then the new denominator is going to be x squared y, x squared y. All of this over the other portion of the complex fraction. And then here we're going to have y over xy plus x over xy. The reason why I'm putting the x in front is because in the numerator, kinda, but the upper half of the fraction, the highest degree is x squared, and I try to write everything in terms of like the highest degree to the lowest. So then from here, I'm going to call this step combine. And this is basically where we combine all of our fractions and kind of simplify them just to make life easy. So we're going to just rewrite everything. 5y minus 3x squared. And since we have least common denominators for both fractions, we're just going to rewrite it as x squared y. And this is still going to be a complex fraction. We haven't escaped yet. All of this over y plus x over xy. This next step, I'm going to call it flip. And this is where we flip the fraction. And the reason why we're flipping the fraction is because I think it's easier, and it definitely helps make simplifying the fraction down the line way smoother. So when you flip fractions, you flip the bottom half of the fraction, especially if you're dividing. So we're going to flip this. This gets flipped. I'm going to write it just in case somebody forgets. So we're going to rewrite the complex fraction as 5y minus 3x squared over x squared y. And then since we're flipping it, just know this is a multiplication sign. I'm just making an x. Forgive me, y'all. And then the new flip fraction is going to be right here. So we're going to take this x over y, and we're going to put that on top. And then this is going to be y plus x. When you flip a fraction, think of it like a pancake, right? If you flip the pancake, it's the same pancake. You're just changing directions. That's all we did. Instead of having y plus x, we threw that on the bottom. We just flipped it over. Nothing crazy. So then our next step is to simplify. We already had this step written out. So we're going to simplify this. One thing I notice is I see an x here and here. And I see a y here and here. So whenever you're simplifying fractions, you can divide the top and bottom. So what I'm going to do, since I know this is x to the first power, this is y to the first power, this is x squared right here, and this is y to the first power. I'm just going to say if I divided an x out of both of these, it'd just be one x on the bottom. So I'm going to rewrite this and simplify it. You know what? Actually, I'm going to do it the long way. Why not? We're going to skip that. So I'm going to multiply both of these together. I'll show those factoring tips in another video. Let's just stick to the basics. Okay. So 5y times x is going to be 5. Oh, now you want to do that. Cool. So it's going to be 5y, well, 5xy minus 3x cubed y. All of this over. Let me page break this. Perfect. I did that so smooth. Man, I have grown. So this, and then we're going to multiply the bottom half. X squared times y is going to be x squared y. Excuse me, this is all one thing. That is incorrect. See, when you don't keep your work clean, that happens. This is an x squared. So x squared y times y, which is all of this times this number. That's just going to be x squared, y squared. And then there is a plus sign in the middle, so we're going to put that here. And then we're going to take this y and we're going to multiply it by, well, this x squared y, and multiplied everything by x. So now this is going to be x cubed, and then y. This next step, I'm going to call it factor. So this step is potentially going to be trouble for some, maybe not for others, but we do have to factor this out, and I'm going to explain. This answer is correct, but your professor, teacher, whoever is going to want it way more simplified. So I'm going to show you how to do that actually. If you look at this term, there's an x here, there's an x here. So we can say, let's take out an x, because there's one in each. There's a y, and then there's a y. So let's take out a y. And then we're going to keep this 5 here. This should have been y squared, excuse me. And then this is going to be 5y. Because when we multiply 5y times all of this, there became 2 y's, because this is y to the 1, y to the 1, 1 plus 1 is 2. We add variable exponents when we're multiplying them. And then we have minus, and since we took an x out of both of these, we're going to be left with 3x squared. We're going to divide all of that. Here we have 2 x's, 3 x's. So we can take an x squared out. Then we have 2 y's, and then we have 1 y. But we can only take 1 out. And then we're going to multiply all of that by y plus x. And if you multiply all of this back in together, you would get the same thing here. I'm about to do a page break or insert space. So now that we're here, we can actually do some more division. This is x to the first power, y to the first power, y to the first power, x to the second. Since we see there's an x here and an x here, we can divide one out. And we can do the same thing with the y's. So when we simplify this, our answer is going to be 5y minus 3x squared all over x times y plus x. This is our final answer. And I'll explain why. Remember how when we had in the beginning, the problem was 5x to the negative 2. And we realized like, oh wait, this is really just 5 over x squared. If you want to take a shortcut, what you can do is subtract the exponent that's on the bottom by the exponent on the top. because the denominator is essentially a negative exponent. Because if we bring this back upstairs, we're left with 5x to the negative 2. All we're doing is rewriting this. That's it. Because x to the first divided by x squared is just x. And here's what it looks like. I might make a mistake, but I feel it's worth giving it a shot. So this is basically saying x to the 1 times x to the negative 2. And if you multiply these two things together, you'll have to add the bases. Minus 2. And this becomes x to the negative 1. And this is the same thing as 1 over x. And that's essentially what this is. I promise my work will get cleaner when I get better with using OneNote, so my work doesn't look hectic. But GTA Math, thanks for sticking with me. I know this was a longer problem, but I wanted to show every step. Didn't want to take a shortcut because I understand everybody's at different learning curves. So have a fantastic day, evening, wherever you're at in the world. Take care.